Well, welcome back, friends. I did not think that we would be getting this far into all the wonderful things you can do with the core. Of course, the reason why we all like to use the core Python tools is that they're tested, they're debugged, and we obviously don't have to install them. They're simply right there on all platforms, no matter where we're running our stuff. As we went from our DBM to our shelf routine, remember the only thing we had to do was to change our bingo in our test case to being a Python string rather than a series of bytes or octets. And moving forward, we won't have to be concerned about having octets because we're going to be using the shelf module to store or persist, if you will, objects rather than simply to serialize our data. What we probably didn't appreciate when we were working with our basic shelf class is that we're actually persisting Unicode string to the Python string class itself. So when we move to using other types of objects on our shelves, we're obviously going to want to persist instances of our classes rather than string. In this case, we're going to simply use our classic person example where we have our name, address, and balance put together. And for those of you who might not know, whenever we create these basic types and associate them to ourselves as we see here, we're actually including them in a dunder or double underscore dict member that we'll be showing you how to use when we create a backup of our data by using delete2. Keeping with the S3D2 way of doing business, there was some significant changes in our shelf class, and those significant changes can be appreciated when we go into our Python 3 organization under the DatMan project to take a look at the 6th advanced lesson called Shelf. And in Shelf, we have our history that will allow us to see the changes that I made, being mindful first to put up a baseline, which was our ADV5 Python, and then went ahead and made my changes and checked them in so that we can see our changes or deltas here, starting, of course, with our name being changed from 5 to 6. That's why we have the green for the most recent, and others following suit as well, up to and including having our class put into our project, and more interestingly, having an object using the PEP or the conventional way of doing things. And if we have a name collision, it's putting an underscore at the end. Some cases I find that wonderful. Some cases, for example, when it's a function, personally I find that annoying. Your mileage may vary. But the bottom line here is what we wound up doing was simply to put our object in as the value and the key, and then create a new instance of our dictionary class and store it as our source, which, as we've come to expect, will be returned whenever we source our project. Because we can have many different types in our shelf, saving an instance of our class definition will also allow ourselves to enumerate only through the types of classes that we originally associated with our shelves. And this is going to come in very handy in version 2, where we store an integral type to keep track of our maximum key values and use our default class definition to make sure that any other type will not be sent to our query or data filtering functions. Everything else is pretty much the way you would expect, having our keys and values accessed at different times. What really becomes interesting is when we get down to our test cases, and looking at our test case, of course, what we're going to see here is the need to make a copy of what is coming into us whenever we create our basic project. In this case, we're going to get our source, as we've seen previously, and then we're going to use our class definition, which was stored from our objects with the underscore at the end. And then we're going to create, just like we saw with our function definition, an instance of that stored class, or the recommended class, and save that instance with my data into it back into our record so as to replace the class definition with the instance of that class. Once we have that recommended instance created, we can go ahead and sync things as we expect. And this time, sync is going to return the record. And we're getting closer to our original pattern here, where we said no matter whether we create or update our record, that sync would always return that record, which would include, in this case, a primary key. Of course, our first implementation simply used the count of the records for our primary key, and being torn between keeping things simple for educational purposes and then keeping things a little more real world, we decided to update this count logic to simply store a primary key in our database, which we'll be talking about later on. But for now, simply understand that we are using a zero-based primary key, which will help us get ready for understanding how we can manage our databases using SQL, and more specifically, SQLite. So now we don't have to provide our keys. We're also guaranteed that each key is going to be unique. The next thing to call your attention to in our test cases, of course, would be the fact that although we did indeed provide an object definition, it's only a suggestion. And inasmuch as we're creating a new instance every time we source our records, we could put any object in here. In this case, just for the sake of simplicity, I simply created more instances of person. So that's to make sure that whenever we sourced our class, we were indeed getting a new instance of our original definition, to make sure, for example, that we weren't overriding the keyed information by making a copy of the source that we provided with our constructor and used as a template in our initialization process. It's only when we take a look at our delete to operation, or the second D in our S3D2 pattern, that we see that we can save or serialize, rather than persist in this case, the copy of our data to our JSON file by using the .dunder_dict that would be associated with any instance of person, let alone any other type of class that we may choose to put on our Python shelf. Because this was a pretty interesting module, I wanted to make sure we could compare our before and after capabilities up on GitHub, and with the sole exception of having our key collision whenever we delete something and then add something that may or may not have the same key, I think you find playing with this class to be interesting, as well as inspiring to manage your own data management projects. About the only thing wrong with this example so far is that if we use the count to get our next key, then if we delete something, of course, we run the risk of having a duplicate key, and rather than creating a new record, of course, we might be updating an old one. To plug that hole, what I decided to do was to come up with a version 2.0 where we simply store another key value pair so that we can keep track of our next key value, thereby ensuring that our updates and creates will work as expected. When we delete a row from our database, we will continue on with the next value, rather than relying upon the count, which of course can go up and down. A surprising amount of changes had to occur to make this simple update, up to and including using a static class member. And if you want to know more about this change, feel free to take a look at the version 2.0 code up on GitHub. Thanks for watching, and I'm looking forward to seeing you in the professional data management and data archival worlds.